And you should be set.
All right. Can you see my screen?
Yes.
Cool. So, so for the demonstration, I wanted to show how replication works. But for this setup, we of course need a source Netezza appliance and a PTS hardware and a target Netezza appliance and a target PTS. So for this purpose, we are using the only setup level available in the lab here in Marlboro. And this same setup is. Hey Mike, I am hearing an echo. I don't know. Anyways, so I'm using this lab setup. So this is the same setup used by the QA team. So they have already set it up, and they use this same setup for load testing and the QA stuff. So they have already installed the PTS software on these boxes. So let's look at a few things that I wanted to show here. First thing I said was let's check the revision of make sure that all the components involved have the same version of the PTS software here. So on the left-hand side top, I have the Netezza master Netezza appliance, the P100, and on the bottom I have the corresponding PTS node, MAL PTS5. And on the right-hand side top, I have the target Netezza appliance, NPS. And on the bottom, I have the target PTS node. Okay. So as you can see, all the components here implement 608P3, so which is what we want. And we can also see the version of Red Hat installed in here. So, so as you can see, 5.7 on the PTS host. So that's what we said is required for the PTS. But the appliance itself is an older version, running 5.5. So there is some mismatch there, but that is fine, operating system level. As I the PTS management software required is shipped as part of the NPS, and that is located in the NZ kit PTS directory. And as you can see, there are two files here, install PTS and PTS.tar. So I wanted to show you guys the installation process of it, but the PTS has already been installed, and but I don't have root access to these machines, so I'm not able to go through and install. But it is as simple as copying these two files over to the var nzRipple directory and executing here. So let's look at the mounts too. So if you look at the fstab file, you can see in the last in the last line here, PTS mount. So this is the IP address of the 10 gig interface of the PTS box, and the var nzRipple directory on that is mounted onto var nzRipple on the NPS box. So it refers to the same location. So we make sure that the mounts are there. Same thing here. Same var nzRipple. Here 11.21 is the directory here. Next, so we have seen the location of the install file. Next, look at the configuration files. So under NZ data, we have this new directory now called Replication. In there, we have we need to place this REPL affirmation file, which is the license file, and the license file is nothing much. It just gives the license key, right? and let's look at the configuration file. So if you look at the configuration file, again, not too much of information here, but here, the replication PTS host, this is where you would specify the IP address or the host name of the PTS machine. Then you can get the same thing from here too, or the quick start engagement checklist. So you would specify that here. And if for any reason PTS is using a default any other port than 52573, you have to specify that here. So that is the location of the configuration file and the license file. Next, let's look at the UID and GID for the NZ user. As you can see, it is 500 on the Netezza host, and it will be the same on here. Otherwise, so that is how it was installed. So 500, same thing. It should be the same thing here too. Of course, it doesn't have to match. Source and target can differ. Sorry, but that is what the default is. So if they keep the default, it will be 500 across the board. Okay. Next thing is the new commands that are part of NZ REPL. So as I mentioned, so they are in the NZ kit bin ADM directory. So you can say, so these are all the new commands that are part of this. Now you can look at that has to be part of course, the profile file. So that will be part of the file. If not, you can add it to the path environment variable. So that is the location of the commands on the NPS host. So that's pretty much on the NPS host. On the PTS host, as I mentioned, there are two important directories. One is var NZ REPL. If you look at the mounts here, there are two mounts here, var NZ REPL and OPT IBM. So OPT IBM is meant for the software, the PTS software, and the var NZ REPL directory is meant for the transaction logs. Okay, so the software, as I mentioned, is already installed on this bot. So if you look at OPT IBM NZ PTS directory, that is where all the install things are. So if you want to uninstall the PTS for any reason, you can execute, for upgrades and downgrades, you can execute uninstall PTS directory. Sorry, you can execute the uninstall PTS script to uninstall the PTS software. So you can go to the bin directory, and that is where all the PTS commands are. There are just a handful of commands that come with the PTS management software. There is this good file called PTS profile, which has a bunch of exports, libraries, and at the end it also has the path to this. Again, as I mentioned, this location of the commands need to be in the path for the NZ user for you to be able to, not to refer to the, not to give the full path when you give the whole, when you execute the commands. Okay. So the PTS software is already installed in here, so you can execute the PTS configure list the PTS configure command to see information about this local host. So when you execute the PTS configure command, it shows the host information, it shows the root directories, and the information about this local host. You can execute the same command on the target PTS, and it shows the information about that host. But as you can see, this IP address is the IP address of the Ethernet interface, not the 10 gig interface. Okay. You can execute the PTS topology command. It will show you what is the local host, what is the local node, remote node, and the clock differential and other good stuff. So here the local is 105. When you execute the same command on the target, you will see that the 106 is local and the 105 is remote. Okay, so you can execute the PTS topology command to see what is all in the topology. But to begin with, you have to use the add command to add PTS to the topology. Okay. You can check the PTS status. It shows the status of the replication here. Okay, there is no backlog. Both the nodes are active. Sorry. So you can execute the similar commands here too. Okay, and if you execute the nzRepl state, it will give you detailed information about the capture log on the detailed information about the status of replication in this environment. So it shows status of the replication capture agent as well as the commit agent, apply manager. Sorry. Okay, so it shows you if there are if it had detected any missed heartbeats and stuff like that. Sorry. Okay, so next, so we have replication is already installed, right? So you can check the status of the replication that is already set up here. So you can say replication select star from replication node to see what nodes are here. Oops. So it shows the node name as P100 and P25, which is the node names that they have given for these nodes. So these need not be same as the host names, as I mentioned earlier. These are the node IDs, 9216112334. It shows the the ID case as well. So so this is one of those replicated metadata views. So wherever you execute, you will get the same information. Oops. Sorry. So you get the same information. But if you execute the mynode view, you will get information corresponding to that local node. You can take a look at the list of replicated databases. So here you are saying this is the list of databases that are being replicated from the master to all the subordinate nodes. So here you can see everything is part of this replication set ID 5083 and the set name as replication set, and this is the DB ID corresponding to replication. So this is not the OID of the database in the database. That is different. So if you execute, if you query for this particular database in v_database, you will get a different OID. So that and this are different.
What's the $DB name there for?
$DB name.
Yeah.
Somebody created a database called $DB name.
Fair enough.
I don't know. Honestly, not very sure. This is a lab system. They experiment with a lot of stuff, and I guess that is one of the things that they did. Not very sure.
Fair enough.
Probably this is just part of the metadata and not an exact database name. Not very sure.
Okay.
Yeah,
If you include a slash before dollar, I think it will come.
Anyways, guys, so
That's what. Yeah.
something that they were probably they were doing. Okay. Where was I? So next, let's look at this replication set node. So it shows the replication set ID 5083. It shows what is master and what is the subordinate and the status for those nodes. You can see replication sync to see the status of the replication here. Let's execute this. So as you can see, the master and subordinate and the last CSN that was executed on the committed on the master is this CSN 263864, and it matches with the node CSN of the subordinate. So that indicates that the master and the subordinate nodes are in sync. Okay. You can look at replication state. So replication state shows replication status for individual databases. So for each database, it shows the CSN on the master and the CSN on the subordinate. So to make sure that all the databases are in sync, and you can query for a particular database to make sure see what the status of that particular database is. Okay. So those are a bunch of system views that are available for us to check this. Next, let's go ahead and create a database. Okay. And as we have seen earlier, the name of the replication set is REPL set. So I'm going to create a database called REPL lab. So it created a database, part of that replication set called REPL set. Next, so if you look at the replicated databases, it should show up in there. So REPL lab, so it got this application ID. So hopefully it made it through already. So it did. So as you can see, this REPL lab made it through the subordinate system appliance. So if you connect to, sorry, there are no tables in there. So let's go ahead and create a table here. Just a sample table. So it created a table, and so it is in flight, that create table statement. So yes, so in a couple of seconds that the table has been created on the target side. Now let's go ahead and insert a couple of records in there. So there are no rows to begin with in this. So let's say insert into table 1. So once it got inserted, and a couple of seconds later, it will come through here into the target side. So that record made it here. Okay. So replication is set up and working. Any update transactions being executed on the master are being replicated over to the subordinate. Next, let's see if we can insert a non-deterministic function. In this case, I'm trying to use the random function, which is non-deterministic. So when I do, the system says that insert contains non-deterministic expressions, and it errored out on me. So it did not execute that insert statement because the setting here for non-deterministic functions in this setup is to error out. So that is why it errored out. Okay, so as I mentioned, so global data can be any users and grants and everything can be done only on the master and not on the subordinate. So let's say if you want to create, if you attempt to create a user on the subordinate, it should error out. So it says a create user cannot be issued on a subordinate node. So these statements need to be executed only on the master side. Okay. So now that we have seen that the DDL and the DML transactions that are being executed on the master make it to the subordinate. So let's look at how this exactly happens in the var nz REPL directory here, which is the transaction log directory where we keep the transaction logs. So if you go to var nz REPL directory in the on the PTS server, there is all important directory is 1. Okay, you go to 1 and there are a bunch of directories here. So the directory that corresponds to the node, the replication set ID will contain the metadata. Okay, so if you go to, it will have what did I say? Okay, so I said the other way around. So the one that corresponds to the node ID will have the metadata. The one that corresponds to the replication set has the actual transaction logs. So let's go back and look at the directory corresponding to the node ID. Is everybody with me here?
Yeah.
Okay. So if you look at this metadata file, there is this REPL state file, and that is the heartbeat file. Okay. This is the heartbeat information for this. So actually, the development team had developed a poster that gives a detailed information about how the data flows through when transactions are executed, and they have developed for this for support team, but I'm going to share. So once after this session, I'm going to make this available so everybody can take a look at this. This provides a bunch of very useful information. So this can be zoomed, and it provides good information. So this one of the things that shows in here is the directory structure of this. So as you can see, the var nz REPL one is the log format major version. So the directory under that with the node ID contains the metadata. So the REPL state file contains the heartbeat information, and there is a timestamp directory, and under that the node file corresponds to the replication node contents of the T replication node. Set file has the contents of T REPL set. Set node file contents of set node file. Set node thing. So if you look at that, let's go to one timestamp directory. So there are 3 files I've mentioned there. So you can look at the node file. So it shows whatever we saw by selecting the select star from V replication node. Set node has the set node information, and set file has replication set information. Whatever. Okay. Next, let's look at the replication logs. Okay, how that is captured. So that is again we are back at this log format major version here. The node ID for this is 9216 and 0, which is the log format minor version. So under this there is sorry, gosh, I'm getting the message here. So the one corresponds to the set has the CD1. This should have the, so this is the REPL set ID. Under that we have the node ID, which is 9216. Right? Under that 0. So if you look at that PWD, var nzREPL 1 5083 is the set ID, 9216 is the node ID, 0 is the format version. So under that you have a bunch of directories. So far we have executed SQL commands. So all those will be captured in the SQL log directory. So as you can see here, SQL log directory has captured SQL update statements. If you go to the SQL log directory, it has other subdirectories it divides transactions. For every 10,000 transactions, it creates a new directory. So the latest one that we created was at 7:46 this morning. So let's go to 986, and we executed 3 commands. 297. So the first thing that we executed was create database REPL lab. So that is the command. It is capturing in this file. So execute as admin, because we have executed that command as admin on the master side. So this probably will correspond to the create table, and the next one will correspond to the insert statement that we executed. So if you remember, we have executed the next command with the non-deterministic function, and that failed. Because that was not captured. So only successful transactions are captured. So if you look at the corresponding the PTS server here, you will see similar information, similar files. Okay. So before we move further, so that is the transaction ID of that, not the commit sequence number. So that is that. So let's look at that. So let's see replication sync to see where things are. Okay. So here it is saying, what is it saying? Node CSN is 263,867, which is different from this transaction ID. So the CSN is different from this transaction ID where it saves these files. Okay. You can see SQL statements being executed by CSN using this command called nzREPL show SQL. If you look at the help, it will show you have to give the set name, which is REPL set, and you have to give a starting sequence number, because there could be a bunch of logs. You want to see what are all the last statements executed. So let's say here everything executed successfully. 263,867 is the last CSN. So if you want to see the last, let's say 7 transactions, you can you can run that command, and it will show you the SQL statements corresponding to those CSNs. So the last 3 that we executed in this session, you can see, are these 3 transactions. Okay. Everybody with me until here?
Yep.
Good. So next, let's go ahead and load a file and see how that works. So let's go to load test and go to our what is that? Repl_lab. Now we are still here. Oops. DT. So table 1 is there. So let's go ahead and create a new table called testload3 in this database. So I'm creating a testload3 same as the structure of another table in another database. So this table is created on the master. So this table also made it through the subordinate. So this table is created as testload3 in here. Next, let's load the data into the table from a flat file. So in this case, I have a flat file called testload3_1 data in this directory, and I want to load it here. So let's execute this command. The data will be loaded in here. So while that is going on, so this is a small file that has been loaded, but let's say if you have any big files, right? So it can take a while to load. So once while that data is being loaded, the data actually gets into this directory called nzpts_temp. So if you see the timestamp being updated on this, so it means that it is as the data is being loaded into this table, it will be loaded in here, and only when the load is complete, it will be moved into the corresponding transaction log directory. Okay. So this
we got a couple questions.
Sure.
One question was, and I think you just answered it. It says, are the replication SQLs also captured in a PG log and then a Netezza host?
Yeah. No, PG log? No.
Okay.
Postgres log is independent.
Okay. And then is Netezza load supported?
nzload?
nzload, yes.
Yeah, that's what I just executed. nzload command. So using the nzload command, I loaded into a replicated database. Okay. So in this, I loaded this table called testload3. Note that this directory need not exist on the target. So this file will be actually moved over from this location to the target location. So you can actually see that. So cd1, what is that? (50839216.0). So in this, there is this directory called SQL data load, which keeps all these load files. So if you look at the latest one, which is today, so 986, transaction identifier, so as you can see, testload3 data. So as it is loaded onto this table, the same file contents are copied over through here in this testload data. So you can see the content. So it will be the same file. And on the target side, you can see that it will move the same target file too. Okay. Same file to the target location, I mean. SQL data load, yeah. So the same test3.1.data file from the source PTS made it through the target PTS, and this is what is actually loaded. Okay, but if you, let's say, if you look at what was the transaction ID that we tested here? So if you look at this nz repl show SQL, so in the last commit sequence number, we are saying that insert into test load 3 from this external table nz load test load 3 1.data. But it will show the same thing here too on the target side. Okay, something not very sure what this means, but 23680. Let's see sync. Let's look at the vReplication sync. Make sure that the transaction went through. So 263,869. So let's look at 263,867. So what we have done here. So as you can see, even the last transaction here, it refers to this directory called nz load state test 3._1.data. But that is not where it loads from. It loads from the load file corresponding to that CSN and the transaction. So the SQL statement might get in here, but it will refer to where it wants to refer to. Okay?
Karen, there's another question. It says, are there any limitations, or what are the limitations in the use of stored procedures to load or update a table?
So you can use stored procedures as long as they refer to any other tables if they are part of the same replication set. Okay? But if you have any cross-database differences in the stored procedures that refer to tables other than these replicated databases, and of course that will fail. Okay? You can call stored procedures only from the master, not in the subordinate. Okay? Does that answer the question? Okay, I hope it does. So we have seen how the data flows over and how nzload behaves, and what happens when you do nzload to load a file and how the file flows through. Okay, so that's all I wanted to demo, guys. So we have seen how, of course, I could not show how to install the PTS management software and create the replication nodes and sets, because they've already been created, and we have seen the management views for information regarding that, and how the information flows through from PTS to PTS through these directory structures. So you can refer to this poster for detailed information about what happens when things are executed on the master. And this poster also shows about some transaction forks as well. If you want, I can show you the events that are available on events. It shows events, right? So you can go to the admin tool and look at the events that are available as part of this application. Any other questions or any other things that you wanted me to show in this demo? Okay, so that's pretty much what I had in mind for this demonstration, Mike. So if you have any other questions, please reach out to me or refer to the documentation available online and refer to the community. So I'll try my if you come to me, I'll try my best to answer any questions that you might have.
Great. Thanks a lot. Anybody have any other questions? Oh, there's another one. It says, can you force a failover?
Yeah. So using that override option, so in the presentation I've shown you earlier, you can alter the replication node to a master, and with the override flag, it forces that node, it promotes that node to a master role forcefully. But again, you have to be mindful of the implications of that.
Okay. Any other questions? Going once, going twice, going 3 times. All right. Well, great. Thanks so much, Karen.
Thank you all for joining this session, and good luck with all your engagement, and happy replicating.
Yeah. Thanks for the great lab. Bye.
Bye.
Thanks, man. It's great.